Hello and welcome to my channel. In this video I'm going to talk about what I did yesterday and today, aka day 4 and day 5 of teaching myself data science. Yesterday I focused on completing the introductory course for the Johns Hopkins Data Science program on Coursera, and in that course talked about in the last two lessons of that course we talked about a couple of things. One was the different types of analysis you can do on data, such as exploratory, inferential, predictory, and causal. Say, for example, the difference between predictory and inferential analysis is that predictory is saying, as in your results, that if one variable occurs or doesn't occur, you can assume that this other thing is going to happen. Inferential is just saying that there is probably a relationship between two variables. We also talked about confounding variables and how to get rid of them. We discussed two ways to get rid of them. One was randomizing potential confounding variables, and the other was fixing them, so making sure that they stay constant throughout your whole data set. I guess one of the biggest takeaways from the introductory course was that your data is not the question you want to answer. Just because you have a lot of data doesn't mean you can really do anything useful with it if you don't have a good question. So the question is the most important thing when it comes to data science. Today, day 5, I started getting into R programming. So far, it makes sense. I think I just need to keep practicing it, because it is a new language for me. I've never used R before, and it's very different. Not very different, but it definitely has quite a few differences from, say, Java or Python. So, some basics of R programming. It has 4, what they call in the course, atomic types, which are logical, which is similar to Boolean; numeric, which is like a float; integer, which is the same thing in Python and Java; complex, which include imaginary numbers; and one more. Let me refer back to my notes. Oh, and characters. What's interesting about this program is that, say you assign a value to a variable x. What that does is it creates a vector that holds the value. It will be a vector of 1 with whatever you put in there, which is pretty different from, say, Java or Python. And some basics on vectors. It's the sort of foundational object in R. Vectors take 2 arguments, the class and the length. You can leave them blank. But they're limited to only one type of object. You can't have multiple types of objects in a vector. If you do try to do that, then R sort of turns the objects you put into the, like, into another type of object. So say you have a character A and a logical true in a vector. The logical true would become a character true, because A cannot become a logical atomic type or data type. Lists in R can have different types of objects. They're very useful. Oh, and I should mention, adding a dimension attribute to a vector in R creates a matrix. So, yeah, all objects in R have attributes that you can change. For example, a vector has the length, the class. There are, or I guess all objects have names, dimensions, class, length, and there can also be user-defined attributes. And there's an attributes function which lists the attributes of an object. Sorry, I'm just refreshing myself a little bit. So yeah, matrices in R, you use the matrix function, and the first argument is what you want to put inside of the matrix. The second argument is the number of rows, and the third argument is the number of columns. And the matrices in R are column first. So if you have a 2 by 2 matrix, and you put the numbers 1 through 4 in it, it would go 1, 2, 3, 4, or I guess flipped if you're watching this at home. You can also bind two vectors to create a matrix, either by the row or the column. A column bind would put the vectors, would sort of horizontalize the vectors, if that makes sense. And the column, and the row bind would make the vectors horizontal. There are also factors in R, and they represent categories of data, such as male or female. Normally, say in Java, you would assign male to the number 1 or something, and female to the number 2, and do your calculations based on that, but R does that for you, which is pretty cool. I feel like that's going to be really useful in writing actual programs in R. Missing values. There are two things. There are two missing values. One is NaN, which is a missing mathematical function, and Na, which is everything else. There are data frames, which store tabular data, stores data in a table in English. Again, something that I'm sure will be very useful. They have so they're pretty much a list where every element needs the same length, each element of the list can be thought of as a column. And the length of each element of the list is the number of rows. The columns don't have to be the same type, which is pretty nice. Oh, and they can be created with read.table, and read.csv functions. Yeah. So another thing, is names. Names in R are pretty unique. You can assign a name to an integer, and it sort of holds that too, and you can call the integer by calling its name. It's kind of like a variable, but like a normal variable. And like normal as in something in, say, Java. Yeah. And you can... Oh, and we also talked about... we also talked about reading table data and writing table data, read table, or read.csv, which I already talked about. Just like brings out a table or from a file. And there are a lot of other functions. Source reads R code, read lines, reads a text file. dget is also reading deparsed R code, meaning which, I guess I should explain with dput first. So dput takes an object in R and deparses it to create a file that is rereadable by R. So you can load this file back in with dget, which is pretty useful. And okay, going back to read.table. So there are some very useful arguments that you can use, or that the function read.table takes. Number one, file, which is the name of the file, or path. Sep, which is the separator, and how the file is separated with commas, spaces, colons, whatever. Column classes, which is probably I think one of the most important ones. Because, R automatically finds out what class each column is in, but if you have a gigantic table of data, it's going to take a long time to find out what class each column is in. So if you just put in manually, it'll save a lot of time overall. Skip, which is the number of lines to skip from the beginning, and rows, which is the number of rows. Comment.char, which is what it should ignore if it comes across, say, for example, a hashtag or a pound sign. Strings as factors. So that just means which character variables should be coded as factors. I'm running a little bit out of time. Oh, and there are file inputs. One is just file, it loads a file, simple enough. GZ file, which opens a GZ zipped file, BZ file, which opens a BZ zipped file, and URL, which gets a file from a URL. Great. Subsetting. Subsetting is quite a long topic. So single brackets return the same class, and you can select more than one element. So say X is a list of, or it's a vector of like numerics. Using a single bracket X to sort of get the index of X would return a numeric vector with just the index. It would be length 1. Double brackets extract elements of a list or a data frame. It only extracts a single element. It can be of any class or it can be any object. The $ extracts elements with using the name that I talked about earlier. You can assign anything to a name, like a number, or a name to anything, better put. Great. Oh, last thing. Really last thing. Yeah, the last thing was removing NA variables or empty variables. And you can do that with the isNA function. Yeah. So you set the isNA, isNA, and then you pass a list or something to it. And then you set that to something, just a name, say, for example, bad. And then you subset the list without bad.